In MCQ 12, this is with regard to catalysis in reaction kinetics. So we are actually using a biological catalyst here, which is actually an enzyme. And the choice of enzyme here that's being mentioned is actually catalyst. So for the case here, hydrogen peroxide will actually be breaking down to form water as well as oxygen. And this reaction is catalyzed by the enzyme known as catalase. So we are trying to find out what's the effect of increasing the concentration of hydrogen peroxide. So if catalase is the enzyme, peroxide here would have been the substrate. Now one thing to note here is that the enzyme is able to react with the substrate because of a particular area on the enzyme known as the active site itself. So this is the enzyme. Let's have this as the active site of the enzyme. And we have the substrate over here, which is actually going to be your H2O2. So we've limited active site because we are not increasing the amount of catalase itself. What will happen here is that we will end off with the scenario whereby we have the enzyme fully occupied with the substrate, and there are still substrate on the outside that has yet to come into contact with an active site, and therefore the rate of reaction would actually plateau after a while, because I'll say that at this juncture here, the active site of all the enzyme is considered to have been saturated. So the answer here we're looking at is actually D. You can see that it is going up as the part where the peroxide, which is the substrate, is actually increasing, because at this black color line portion, I'll say that there's still sufficient active site on each of the enzyme available to deal with the increasing substrate. But at this portion where it actually starts to plateau, this is where I would say that the active site is saturated. So that means that we need to wait for the enzyme to eject the substrate, which is peroxide, once it have actually been broken down to H2O and O2. So visually, we're looking at this scenario here, whereby the enzyme will actually have to eject out the products of the reaction here. So the products, we're looking at H2O as well as O2. This frees up the active site for the next substrate to actually enter, so that reaction can actually continue. The rate doesn't slow down, it's just that the rate plateau because the active site at any one time is all fully occupied. So once again, the correct answer for this question here is D.